Yeah, in our previous class, we had discussed about the SFCs, the sequential function charts, right? How exactly the SFCs can be conceived in a PLC scenario, right? And after that, it is state representation of different transitions as well as the outputs. I think we have already seen the example of a traffic light, right? How sequentially you will be able to glow the red light, amber light, or green light. And even we have taken an example of washing machine also, right? How the different washing machine cycles can be conceived with the help of the sequential function chart. So after that, I think we have even seen what exactly we mean by branching, right? So how would you have the branching and how would you have the conversions? This also we have seen, right? So now branching something like this, you have some state, some output, then from this it is possible for us to have multiple inputs here as well as the multiple states in terms of its outputs, something like this, right? So this comes as the branching, and the convergence will look something like this. We have, say, two states here. They converge depending upon the different inputs. Let me call this as ST1 and ST2. So depending upon IN1 and IN2, you would go to the next state, which we call it as ST3, something like this, right? So this is what we call it as the convergence. And accordingly, let us try to take one example here. I don't know where exactly we had stopped in the previous class. Uh, Please note down this example, very important even from the point of view of examination, right? So first note down this circuit. I would draw a circuit something like this. Let us take the example which is relevant to our context, electrical engineering. It is something like this. So here I have one switch followed by a motor, something like this. This is mains. Then further here I have something like this. I have got one more switch here. Then it would go this way. I've got one more switch here. Now here let me say that I have got an indicator, something like this. Then I have the structure, something like this. One, two, three. So this is motor M1, then this is M2, M3 and M4. So this is one indicator. All of you please draw this parallelly. This is the indicator. This is, say, S1. This is S2 S3 and S4. Maybe this motor here, we can take it as liquid level indicator. And this pump, motor M1, is acting as a pump, okay, to pump the coolant to a tank. And these three, M2, M3, M4, are the working machines. Working machines. All these three motors, all the motors, M1, M2, and M3, M3 operate for 15 minutes since their start. Since their start. So this is what is a scenario, what you can see in this diagram. You have got the mains, then you have got a motor M1, which is say a liquid level indicator or something like that, right? So, and this motor M1 is the, the physical device. The liquid level indicator is a kind of sensor there, right? The action is when you turn on the switch S1, okay, the motor will turn on and it will pump the coolant into a tank. So once the tank is filled up with the coolant, okay, so your other operations should begin, followed by maybe the indicator. One second, there is one more switch here. Let me call this as S0 here. This will be S1, then S2, S3, S4. Okay, so you have got five different switches here: S0, S1, S2, S3, and S4. The operation is something like this. When you turn on the mains, of course, with S0 and S1 in the off position, the mains will be turned on. So what would you do is, you will turn on S0, that in turn turns on the motor M1, which is a pump basically, okay. So it will lift the coolant into a overhead tank or something like that. Once the overhead tank is full, how would you get the indication is by virtue of a liquid level indicator. Here the sensor comes into picture, right? So now you try to correlate with the sequential function charts, wherein you have got the start, then you have got the transition, right, or some input, then the transition, then the output. This is what we have already seen earlier, right? So now S0 is one action input. So your motor getting started or the pump getting started, the coolant is getting filled in the overhead tank, right? So that is the process there. Then the liquid level indicator, right? So that will give you the output, a kind of output that it has reached this particular value. So afterwards, your motor M1 will be turned off, or here whether the motor M1 is turned off or not is not important for us. Followed by that, what would you do is, you will turn on the switch S1, and an indicator okay, would glow there, right? Of course, this particular diagram doesn't properly represent that, right? So now once you, let us assume that when S1 is turned on in this diagram, your indicator will glow here, right? So once the indicator starts glowing, upon turning on of S2, S3 and S4, right? All the three motors will run for 15 minutes since their start, right? The moment you turn on S2, M2 will be turned on and it will remain on for 15 minutes. And again, needless to mention that after 15 minutes, it will be turned off. There will be a timer or, you know, a normally closed or normally opened type of push button switch, which is going to act, which we have already seen earlier. Then again, S3 will be turned on, M3 will be turned on for 15 minutes, S4 will be turned on, M4 will be turned on for 15 minutes. Now, whether S2, S3, S4, they are simultaneously turned on or they are turned on in a sequential manner, that all depends upon the operator. That is not specified here. We know that only upon turning on of S2, S3 and S4, the corresponding motors M2, M3 and M4 will be turned on for 15 minutes, and after the 15-minute time is elapsed, right? So the motors will be automatically turned off. So this is a kind of situation where you have the operations to be carried out in a sequential manner, right? So now for this particular example, what we need to do here is draw the sequential function chart for the operation shown. Draw the sequential function chart for the operation shown and also the ladder diagram and instructions. Ladder diagram and instructions. So this is what we are supposed to do here in this example. Now let us, this is very simple in fact, right? But the way in which you write the points or the terms there, it may vary from person to person, that it cannot be the same for all the people, okay? So first we are supposed to draw the, you know, sequential function chart, right? So from where would you begin? Mains being on, that is our starting stage, right? So the mains that is being on, that will be the starting stage. So what I want to do here is, you can see here, I will draw the start block, something like this. So start block is always having a double entry here in the column, right? So what I will do, I will write here is mains on, mains on. So this is what is my start. This is from where I start, okay? Then next, here you will have a transition. Please have a look at the diagram, right? So now this transition is referred to as S0 pressed. So your entire operation subsequently, after having seen the mains on, it starts from S0, S0 pressed. So this serves as IN0, the input 0 here. This serves as the input 0. So what is the process there? The coolant pump M1 being on, right? So therefore what I should consider here is one more block I will consider here. Okay, if you want you can just write it as M1, or if you want you can write it as coolant pump M1, coolant pump M1. So this is what is my first process, right? I have my mains on, I have started. Now upon pressing S0, right, my coolant pump M1 is on, right? So now what is the action that is taking place here? The overhead tank, okay, with the provision of storing the coolant getting filled into the required level, right? So that's what is the transition. So now here I will have to have one output, something like this, transition, input, transition, process, and the output. So here this is fill the coolant to required level. I will redraw it, draw it little big. So I will make it little big here. Yeah, something like this. Fill the coolant to required level. So this is going to be my output, the first output or the first transition. This I call it as out 0, in 0, out 0. Now from there I am coming to the other side. Please look here. I am coming to this side now. So what will be my next step here? Upon receiving the signal from the level indicator, right? So what I would do is I will turn on my switch S1, right? So now how would I come to know that some action has taken place? Visibly I can see the coolant level to some value, or the motor getting turned off or something like that, right? But from the point of view of the electrical signal, I should get a signal from the liquid level indicator that it should give me a kind of electrical signal. The liquid level indicator being a sensor here, it will give me a kind of signal. So when that signal is obtained, what I will do here is I will go to the next step, that is the liquid level indicator. So this is my liquid level indicator. There is some problem with the network. That's the reason why I'm not able to write it properly. Anyway, so liquid level indicator, the output of the liquid level indicator would push me to go to the next status, wherein I have my S1 here. I have S1, and this S1, upon pressing S1, what I will do? I will see the glowing of the indicator here. It is the indicator. It is the indicator which is going to glow. It is the indicator which is going to glow. And here, this is my IN1, and this is going to be my out 1. So once the indicator glows here in this diagram, once the indicator starts glowing, now you would go with the branching operation, what we have discussed in our previous class, the branching operation. So branching operation, now once the indicator starts glowing, now it is your liberty as a user to turn on S2, S3, S4 either at a same time or sequentially or randomly, which has not been mentioned there. But when S2 is turned on, the motor M2 will be turned on, S3 is turned on, M3 will be turned on, S4 is turned on, M4 will be turned on, and they will remain turned on for 15 minutes. So now from here, what I should have is a branching. Here I should have the branching. So now once I got out 1, I will come here. So and again I will take, this is like this way, and this way. And now you can have the transition here for M2. This is for M3, and this is for M4. So now this will be your IN2, this will be your IN3, and this will be your IN4, and accordingly you will write this as S2, S3, and S4. S2, S3, and S4. Now this S2, S3, and S4 would make your M2, M3, and M4 as the processes here. This is M4. Now here these are the outputs. What we can write it as out two, out 3, and out 4 here. Now when the process gets completed here, now let there not be any confusion, I have written them in the vertical manner. In fact, these things should have been in the horizontal way. If you look at the previous stages or the steps, right? So just try to understand here that when your input 1, go back to the input 1, which is your S1 is obtained, the indicator will turn on, which is the output. So upon receiving the indication of the indicator, which in our language is out1, okay, out1 and your IN2 will result in the turning on of the motor M2. Out1 and IN3 will result in the turning on of M3, and same way out1 and IN4, every time when I say out1 and, that word you will have to listen to me carefully, and because we are doing some logical operation here, right? So out1 and IN2, out1 and IN3, out1 and IN4. So these things would make M2, M3 and M4 to be turned on, right? So now we will have to come to an end here, but before coming to the end, right? So we will have to have some kind of transition. So that transition is nothing but the timer here. We have not yet discussed about the timers because we have been told that the motors will work for 15 minutes since their start. So therefore, the moment the switch IN2 is turned on, okay, so you are also starting a timer, a down timer or something like that, which will start from 15 minutes, which will become 0. We will discuss about the timer operation later when it comes in our syllabus. So once the time is elapsed, a kind of signal is going to be given. So that signal will turn off the corresponding motor, M2 or M3 or M4. Okay. So now here, after out 2, you have the timer, you have timer, let me call this as 1. Here also you can call this as timer 2. You can, if you want, you can realize all these operation with the help of a single timer also. That is also possible. So this is the timer 3. So now all these operations would converge the operation into an end operation. You can write it separately also, because when exactly a motor gets turned off, that we do not know. That all depends upon when your switch S2 or S3 or S4 are turned on. So accordingly, you will have to have the end here, right? So now probably you should be able to understand why I told in the beginning that the thought process here will be different from student to student or person to person, right? But the sequence should remain same here, right? You have started, you have made the mains on. Upon having the transition, that is S0 is pressed, your coolant pump will be on, and the output here is filling the coolant up to the required level. Then the liquid level indicator will push your switch S1 on, which is your IN1. So the output is the indicator. The moment the indicator glows, right, depending upon whether S2 or S3 or S4 is turned on, your corresponding motors M2, M3 and M4 will be turned on for the specific duration, which is again taken care of by the timer 1, 2, 3, or maybe a single timer depending upon the requirement, and you will get an end statement there, right? So this is how you write or you draw the sequential function chart, SFC, for this particular program. Now we will try to write the ladder diagram or draw the ladder diagram for the same. So I would first draw the rungs here, the 2 rungs of the ladder diagram. Drawing a ladder diagram would be simple here. Now assuming that your mains is on, you have started from that particular assumption, the mains is on. So I will first take one input here, something like this, followed by its corresponding output. So which is the input here? IN naught. IN naught is the input and out naught is the output. So this is to begin with. IN naught, you can even take it as X400 as per our nomenclature which we have seen, X, because that would be easy for us to draw the instructions. X400, and here I will take it as Y430, Y430. So this is going to be my first rung. Followed by that, I have got one more input, that is IN1, the switch IN1. So I will write it here, and this will make your indicator to glow. So this I will write as IN1, and this will be out 1. So I can write it as X401 and Y431 here. I can write it as Y431. Now, next comes the parallel branching. Right? I have come to IN naught, out naught, IN1, out 1. Now, see, you have the parallel branches, that is, whenever your indicator is on, that is out 1 is on and IN2 is on, you will have the out 2 on, right? So therefore, what I will write here is your input rung, whatever I am going to consider here, is as a result of Y431, and there is one more input. This will take your output out 2. I will draw the subsequent rungs also, something like this. You also should be able to draw these things on your own. So this I will write it as Y431. This is also Y431. This is also of course Y431, and this is going to be your IN234, IN2, IN3, and this is IN4. So this is going to be your out 2, out 3, and this is your out 4. So we can write in terms of X 402, X 403, and X 404. So this will be Y432, Y433, and Y434. 34. So after all these things, you would come to the last part of it, that is the end run. You have end. This is the simple ladder diagram which we can write for the given example. So when Y431 is present and your other inputs are present, you can, instead of that, you can avoid the two more switches of Y431, something like this. This is Y431 and one more switch, something like this. You can have this way also, that makes your things more structured, this way also. Okay, so this is why 431, and these are the three inputs, that is X402, X403 and X404. Right? When all these conditions hold good, then only you will be able to have your output. This way also you can draw. Okay. Now for this you will have to draw the, or you will have to write the instructions. Let me write the instructions right in front of it. It is very simple, everyone can write on their own, right? Again, it will be a practice. So the first rung is LD X 400, then followed by this out Y 430, out Y430, then again LD X 401, out Y 431. Now LD Y431. Please note here, the input switch happens to be as a result of output Y431, right? And X402, out Y432. Again you will have to go with LD only. LD Y431, because this Y431 comes 3 times repeatedly, and X403 now would lead us to the output Y433. Then again LD Y431 and X404 would take us to out Y434. 4, 31, 32, 33 and 34. Then comes the end run. This is how it has to happen. Now based on this, probably you should be able to make some changes in the problem statement itself so that you can have the other kind of operations also coming into picture, that is and apart from and you can have the OR operation, XOR operation, right? So as time progresses, let us try to see some more kind of examples when we come across other kind of situations, the different situations. So this is one important example wherein you have the sequential function charts drawn for a particular example or a particular industrial scenario, a simple example. I hope all of you have followed this. Let us try to take one more very important example, that is, all of you know synchronization of alternators. Synchronization of alternator to the bus bar or with the bus bar. Some of you have already conducted this experiment also. Now, having PLC here, right, I can always give a feature of auto synchronization of alternator to the bus bar, right? So your presence need not be there if at all you want to synchronize an alternator to the bus bar. So now, first let me draw a small diagram here. So let us say that this is R phase, this is Y, and this is B, and this is R, Y, and B, something like this. Then on the other side, I would draw the machine here. This is the alternator, okay, and let me have a switch here, the synchronization switch. You know what are the different conditions to be fulfilled as long as the synchronization is concerned, right? The voltage of the incoming alternator should be equal to that of bus bar voltage. Okay, so what will you write there? VA, the alternator voltage should be equal to the bus bar voltage. Then frequency of incoming alternator should be equal to frequency of the bus bar. Then phase sequence should be same. That means the phase sequence of the incoming alternator should be equal to the bus bar phase sequence. So for this particular purpose, you have two things here, which is very common aspect. One is the prime mover. These backgrounds you should try to understand. This is one thing. The second thing happens to be the excitation. So this is exciter, TER or TOR, anyway. This is the exciter. So you know very clearly that this is the bus bar. This is a bus bar. So these three conditions are to be satisfied. One is the incoming voltage of the alternator should be equal to the bus bar voltage. The second thing is the frequency should be same, the phase sequence should be same, right? So now you try to give it a feature of the PLC application, right? You know how to do all these things, right? So now what you will do is you will connect one voltmeter here, something like this. So this voltmeter should read 0 because whatever V I have taken here, this is the difference between VA and VB. It should be 0. Then only you can say that VA is equals to VB. Okay. So that is done. That is done with the help of the excitation. Right? You change the excitation, bring the voltage of the alternator to that value of the bus bar. This is one thing. Then the second one is the frequency. Okay, so for the purpose of frequency, you are using the prime mover. You change the speed of the prime mover, ns is equals to 120f by p, formula you know, right? So frequency you will adjust it to 50 hertz in the Indian scenario, right? So that is the bus bar frequency. That is done with the help of the prime mover. So there also you get some kind of indication, sensor kind of thing. Okay, so whenever this voltmeter reads 0, your one condition is satisfied. Whenever you may have some frequency meter here connected, right? Whenever the frequency meter shows the difference between the two frequencies as 0 or this frequency as 50 hertz, then your second condition is fulfilled. Then you may have the phase sequence meter. Phase sequence meter is also present, right? So which will give its own kind of signal that the phase sequence is also same. So once the phase sequence is same for the incoming bus bar and the alternator and the incoming bus bar, then you would close this particular switch, whatever we have here, right? So this particular thing has to be executed in the sequential manner. First check the voltage, then check the frequency, then check the phase sequence. When all the three conditions are satisfied, you close the switch. You take some action so that this particular switch is closed, right? So this is what is the problem to be executed, and this has to be written in the form of the sequential function chart and corresponding function, the instructions, right? And even the ladder diagram should be drawn for this, right? So these things we shall see in our next presentation.